Alright guys, great, welcome to the question number 2 discussion on this question, a very interesting question. Let's take a look. Question 2 says, is the standard deviation of the numbers a, comma b and c equal to the standard deviation of 4, comma 8 and 12? Statement 1 says 2 into bracket c minus a equal to 16, and statement 2 says 5b minus a equal to 4 into bracket b plus 1. Alright, great. So again, like we discussed in the first question, we need to know some concepts. And what concepts? Obviously the concept of standard deviation. Alright, so let's take a look. Let's refresh this concept of standard deviation. Standard deviation, there is a very dreadful formula. It is square root of summation of x minus m the whole square upon n, where m is the mean of all values of x, n is the number of values, x are the individual values, summation sign is that, and the whole square root. It is a horrible, dreadful formula, I know, but we're gonna break it down and understand it very easily. Okay, rather than go with this formula, we're just gonna understand what deviation is and what standard deviation is, and we're gonna look at an example which is 1, 2, 3. So don't worry at all. I know this formula doesn't, it's almost dangerous and a devilish kind of formula, but don't worry at all. We're not going to use it. First, what we're going to do is find the mean and the deviation of each term from it. Alright. Mean, you might recollect, is the average. You find the mean by taking the sum of all the numbers and you divide it by the number of numbers. In this case it will become 2, right? So it's a middle number in this case. Now look at the deviation of each term from the mean. So if you look at the deviations, if you see 3, it is 1 away from the mean. Okay, 2 is 0 away from itself, right? Because 2 is the mean, and 1, the deviation is minus 1. Alright, so this is our first step. Just always look at the deviations from the mean. Second step, we take the squares of the deviations. Alright, just take the squares. So if you square minus 1, you get 1, square 1, you get 1, square 0, you get 0. Add these squares. Alright, so add all these values. You are gonna get, in this case, 1 plus 0 plus 1, which is 2. Take the average of these squares of the deviations is 2 by 3, and take the square root, which is square root of 2 by 3, and ST is root 2 by 3. Alright, again, there are a lot of steps involved. Don't worry at all. With a little practice, you're gonna get these steps. But most important, you might not even need to find the SD. I'll show you in this question that you may not even need to finally calculate the standard deviation. You only need to know what are the deviations from the mean. So from 2, 3 is 1 away, so that's your deviation over here. From 2, the deviation is 0, that's over here. And from 1, the deviation is minus 1 over here. This is the most important thing to remember, because standard deviation deals with deviation relative to the mean. Alright, now just for practice, I want you to try one out, and we have to find the SD of 4, 5, 6. So step 1, find the mean. Alright, add all of them, divide it by 3, you get 6 plus 4, 10, 10 plus 5, 15, 15 by 3 is 5. Alright, so mean is 5. Find the deviations from the mean. So again you have the same deviations. 6 is 1 away, right? And again we have 5, so 5 is 0 away, the deviation is 0 itself, and 4 is minus 1. And so, if you square it, you get the same numbers. If you take the average, you get the same numbers. If you take the square root, you get root 2 by 3. And hence, therefore, you get the same SD. So notice, if you have the same number of terms and the same deviations from the mean, your SD will be the same. Alright? Great. So that is the key observation on this concept. Standard deviation of two sets which have the same number of elements and which have the same deviations relative to the mean will have the same standard deviation. Alright, so keep that in mind. Two sets which have the same number of elements and which have the same deviations relative to the mean will have the same standard deviation. For example, 1, 2, 3 will have the same SD as 4, 5, 6 that we already saw, but again which will also have the same SD as, for example, 10, 11, 12. which will also have the same SD as 100, 101, 102, and so on and so forth. As long as you have 3 terms and the deviations are going to be the same, the SD will remain the same. Similarly, 4, 8, 10 has the same SD as x, x plus 2, x plus 4. Why? Because if you notice here there are 3 terms, here also there are 3 terms. Here the deviations from the mean are, the mean is 8, right? If you add it all up and divide by 3, you get mean as 8. The deviation would be plus 2, minus 2 and 0. Here also if you observe, you have 3 terms, the mean would be the middle term x plus 2, because if we add it and divide by 3, we would get the middle term x plus 2. And here the deviation from the mean again would be plus 2 on this side and minus 2 on this side. So deviations are going to be minus 2, 0 and plus 2. So both these two sets have the same deviations from the mean. The number of terms are the same, and hence the SD will also be the same. And the answer would be independent of x. Alright. So now let's apply these concepts. Is the SD of the numbers a, b and c equal to the SD of 4, 8, 12 is the question. So first, let's look at 4, 8, 12. Alright, so 4, 8, 12, you again see is an arithmetic progression. Arithmetic progression we'll discuss again later, but you can just observe that they are evenly spaced, right? So the mean is 8, you add them and divide by 3, you are going to get 8. Deviations from the mean are going to be 4, right? Because 8 plus 4 is 12. The deviation of 8 from itself is 0. And the deviation of 4 from 8 is minus 4. Now this is the important one. Actually, in many questions we don't even need to go ahead and find SD. Even in this question you will not need. But I'm just gonna go ahead just for getting used to the SD calculation. Calculate the square of the deviations. So we square it, 16, 0, 16. Take the average. Average of these numbers would be 32 by 3, right? 16 plus 16 is 32, and there are 3 terms, so divide by 3 and take the square root. It is root 32 by 3. Alright, okay, but like I said, just keep this in mind, okay, that the deviations are minus 4, 0 and 4. And now let's see the statement 1. Statement 1 says c minus a equal to 8. Does it give us enough information to find SD of a, b and c? Answer is no. Why? Because we know that, okay, the difference between c and a is 8, but do we have any information relative to b? No. And statement 1 is not sufficient, right? Or we can say, like we used the short form earlier, that we're gonna say this is NS. Alright, now let's see statement 2. Statement 2 says 5b minus a equal to 4b plus 4. Alright, let's rearrange that. Rearranging gives 4b comes this side, so 5b minus 4b is going to become b, minus a, we're going to leave it over here, equal to 4. So again we find that the difference between b and a is 4. But again, this statement 2 alone does not give us any information about how is c placed, right, with respect to a and b. And hence we do not get an idea of the standard deviation of a, b and c. Answer is no, we do not get any information. So 2 is also not sufficient to answer the question, because we can't compare the standard deviation of a, b and c with the required 3 numbers. Hence we can therefore conclude that statement 1 is not sufficient. Statement 2 also is not sufficient. And at this point, you may recollect, is the point where we will combine the 2 statements. Only when 1 is not sufficient, 2 is not sufficient, we will combine the 2 statements. Alright, let's combine. Statement 1 says c minus a is equal to 8, which implies that c is 8 more than a. Statement 2 says b minus a is 4, which implies b is 4 more than a. Now, at first glance, right, you might not observe, it might just appear that even these 2 statements, even if I combine, does not tell me anything about SD, okay? But just we have to look a little bit more closely. What will we observe? That b is 4 more than a and c is 8 more than a. Hence, doesn't it look like that A, B and C are equidistant from each other? And to see it more clearly, suppose that B is x, alright? Then A would be x minus 4 from that equation over here, right? It is 4 less than B. C is going to be 4 more than x, right? Because if you combine this, you realize that C is 4 more than B. Hence, we'll get C as x plus 4. Thus, the three numbers become x minus 4, x and x plus 4. Thus, you can see the equidistant nature. The lowest number A is 4 less than the middle number B, which is 4 less than the bigger number C. All of them are equidistant. Thus, what can we say? Can we say the mean is x? Yes, because if you add these three and divide it by 3, the 4 is going to cancel and we're going to get 3x upon 3 and the mean is going to be x. What can we say about the deviations? The deviations over here is 4 more, right? So the deviation of the largest number is 4 from the mean. Deviation of the middle number is 0. It is itself, right? And the deviation of the smallest number over there is minus 4. It is 4 less than the mean, alright? Now, at this point, you can continue and find the SD, but actually not required. Why? Because what we have seen is that the earlier set that we had, 4, 8, 12, also had a mean of 8 and the deviations were minus 4, 0, 4, right? And this set that we have also has 3 terms and the deviations are minus 4, 0, 4. Now, you might recollect from the earlier calculations that SD only depends on the deviations, like I said, and also depends on the number of terms. These two have ended up having the same deviations from the mean. Also, both of them have the same number of terms. Hence, if you go ahead and do the calculation of SD, which you can go ahead and do it for this case, you're going to find that the SD is going to be the same. Thus, together, we can answer the question that the two SDs are equal, right? So, the two statements together are sufficient. Hence, the answer is C, together sufficient. Hope that is clear. We can recap quickly. We know that from this observation that A, B, C look like they are equidistant, and here's a way to see it more clearly. We could say that B, the middle one, is x, the A, which is the smaller one, is 4 less, and C, which is the bigger one, is 4 more. So what we observe is that the deviations are minus 4, 0 and 4, right? From the mean, the deviation is minus 4, 0 and 4, and hence it has the same deviation as the earlier one, the one that we need to compare with, which is 4, 8, 12, which also has the deviation as minus 4, 0, 4. Hence, the two statements together are enabling us to answer the question that the two sets have the same SD, hence it is sufficient, and the answer is C, together sufficient. Awesome. Let's try a little bit, playing around now. What if scenario? What if statement 1 was C minus B equal to B minus A, and statement 2 was 5B minus A equal to 4 into B plus 1? Statement 2 I've left it as it is, but statement 1 I've just changed it a little bit and said that C minus B equal to B minus A. Now observe, the statement 2 will be not sufficient by itself because of that we've already discussed in the previous question. But statement 1, how about it? Does it tell me anything about the SD? Well, it does tell me that the difference between C and B is the same as difference between B and A, and therefore A, B and C are equidistant as we in the previous one. But only problem is we don't know what those deviations are, right? We don't know what those deviations are, so we won't be able to compare with the original question. But if I combine these two statements, the statement 1 again tells us that the deviations are same. Statement 2 tells us that B minus A equal to 4, right? By rearranging we'll be able to say that B minus A equal to 4, and hence the statement 2 is giving me that this deviation is 4, it's saying that c minus b is also 4. So we can say by the same logic as we applied earlier that the 3 are x minus 4